In this video, we're going to go over some solutions that are very similar to the problems in the study guide. So, before you start attempting the problems, I want you to study the study guide and provide number one, the quadratic form. So first, we want to identify the quadratic form, and then number two, what is the problem asking us? So what do I need? Okay, so after you identify the quadratic form and what do I need, what is the question asking you, you should be able to solve these questions pretty easily. So first, what kind of form do we have here? Well, this is going to be a standard form, quadratic, and what I want is going to be the vertex and the axis of symmetry. So I want the vertex and I want the axis of symmetry. I would just put SOS, AOS. Okay. So from the standard form, we know that our vertex, we can use the formula for the vertex. We use the formula x is equal to negative b over 2a. Let's see if I'm in frame. Okay, good. So here my a is negative 2, my b is 4, and my c is 1. So I plug it in. Let's see, negative 2 over 2a. Oh, no. This is 4. Negative 2. Right, so we have negative 4, and then on the bottom, 2 times negative 2 is negative 4. So we just have positive 1. Okay, so finding my vertex, this value, this is actually going to be my axis of symmetry. So axis of symmetry is x equals 1. This is an equation. Right, so at let's do negative 1, negative 2, 1, 2, and then so on. So this is saying that 1, my axis of symmetry is going to be, it's going to be right here at x equals 1. And our parabola is going to go up or down. But since we know it's negative, we know it's going to go down. And then our vertex is going to be somewhere on this line. So to find how high my vertex is, I just plug my 1 into my quadratic. So I find f of 1. So then this is negative 2, 1 squared plus 4, 1 plus 1. So negative 2, 1 squared, that's just 1. 1 times negative 2 is negative 2. Plus 4 plus 1, negative 2, 2, 3, so 3. So then my vertex is in my x value, this one, and my y value, f of 1. So we have my vertex is given by 1, 3. Okay, so then again, axis of symmetry given by this equation. My vertex is given by this. And double checking, we have our right solution. Okay. Let's do another problem. So suppose we have this form. What is this form? Okay, what is this form? It's not standard because standard looks something like this. So it's not standard. This is what we call our vertex form. Our vertex form, it's called the vertex form because you can identify the vertex immediately from this. So the way you do this is you set x minus 4 equal to 0. And you get x is equal to add 4 to both sides. So that's my x value. My y value is going to be this. Because if I plug this into my equation, f of 4, I'm going to get 5. 4 minus 4 squared plus 7. 4 minus 4 is 0, so we have 5 times 0 plus 7. And this gives us positive 7. So my vertex is 4, 7. But remember, up here, let's see, the vertex for this one was 1, 3, so somewhere right there, right? Let me put it in a different color. 1, 3, and it's gonna go somewhere down like that. Okay. What is the axis of symmetry? Well, this is just the x value. The x value of my vertex. So if I know my vertex, then the axis of symmetry is just x equals 4. That's my axis of symmetry. Okay. So again, axis of symmetry, x equals 4, and vertex 4 is equal to 4, 7. Okay. Let's do another one. Okay, so finding the x-intercepts. So whenever you hear x-intercepts, this is where it crosses the x-axis, right? My parabola can probably look something like, let's see, something like this. Our x-intercepts is simply the point right there and right there. So another word for x-intercepts is zeros, or another word we use is roots, or another word that we use is solutions. So all of these mean the exact same thing. Where does it cross the y equals 0? Okay, so we want to figure out where does it cross it, and when we talk about x-intercepts, zeros, roots, solution, we always set it equal to 0. So whatever our quadratic is, we're going to set it equal to 0. Okay, so first, actually, before we do that, we got to identify our quadratic form. So what is my quadratic form? It's going to be in factor form. And the reason why we call it in factor is we don't have a x to the square power because we broke it up into 2 factors. So here, we're going to set it equal to 0. So we're going to grab this, bring it over here. 0 is equal to x minus 2 and x plus 9. So if it's already factored like this, then to find the x values where it equals 0, we simply break it up. X minus 2 is equal to 0, and x plus 9 is equal to 0. Here we get x equals 2 by adding 2 to both sides. Here I subtract 9, I get x equals 9, negative 9. So then my solution, my x-intercepts are going to be 2, and that's going to be my y value, 2. And how high does it go? It's going to go at y equals 0. So that's why we have a y value of 0. And here, -9, 0. Okay. So my x-intercepts are going to be this. That's going to be my solution. This is my solution. Double checking, we get the correct solution. Oh. Okay. Let's see. Let's do Okay. Let's do number, whatever number this is. So first, what form do we have? We have a standard form, right? We have a standard form, and we want to find the vertex by completing the square. So we could use x equals -b over 2a, but then that's not what we need to do. We got to do completing the square. So to complete the square, we simply rewrite it. X squared minus 10x, and then I'm going to give myself some space, plus 13. Here, do I have anything in front of the x squared? If I do, I need to factor that out. If I don't, I can move on to the next step. So here, I don't have anything inside, so I move on. And here, I'm going to divide by 2. So -10 divided by 2 is going to be -5. And then I'm going to square it. If I square -5, I get positive 25. Okay, and here, since I added 25, I added 25 to my equation on top. I need to subtract, or we're going to add -25. That way, it doesn't affect our quadratic, and we're just rewriting it. So if I add 25, I get to add -25. Okay, and then this becomes x plus 13 plus -25. And now we just simplify. Remember, this is still f of x. Bringing it down, rewriting everything. We're going to simplify this. 13 minus 25 should be -12. Okay, and then from here, what is the vertex? The vertex is going to be, set this equal to 0, x minus 5 equals to 0. So x equals 5, and then if I plug it in, that goes away, and I get -12. So just to double check, f of 5 is going to be 5 minus 5 squared minus 12, and I get 0 minus 12, so -12. So then my vertex is -12 and x equals 5. Okay. So vertex is this. My completing the square is this. We did complete the square. I forgot to add the solution here for the vertex, but this is our vertex. Let's see. Let's do another completing the square. Looks Looks like I didn't put one in. Okay, here. Let's make one up. Let's do f of x is equal to, let's do 6x squared plus 24x minus 19. Okay, and I want to complete the square. Okay, so again, we're going to rewrite it. F of x, 6x squared plus 24x, give us some space, negative 19. Okay, here. In the previous problem, where is it at? In the previous problem, we had a leading coefficient of 1. We have a leading coefficient 1, so we didn't need to do anything. But here, what is our leading coefficient? It is 6. So what we have to do is we need to factor a 6 out from the first term and the second term. We leave the 19 alone because we moved it away. It's still in the equation, but it's moved to the right. So what we got to do is we got to factor out 6. So 6 divided by 6 is 1 x squared. And then how can I factor out a 24 out of, how can I factor out 6 out of 24? Well, that's going to be 4, I believe. Yes. So we're going to have 4x, and then we still have our space, minus 19. So we haven't done anything. We just factor out 6 from the first term and the second term. So we have 1x squared plus 4x, and then whatever goes in here. Now we could apply completing the square to the inside. So what we can do is do the exact same thing. Bring down the 4, divided by 2. We get 4 over 2, that is 2, positive 2. And then we're going to square it. That's going to be 4. Okay. And now let's bring down the x, and then let's also bring down the 6. Okay. Now, since I added positive 4 here, I need to add 4. But since we have the 6 in the front, we do not just add 4. We need to add a factor of 6 as well. So here, it would be 6 times 4. Oh, so this is positive 4. This is going to be minus 4, minus 4. So negative 19 plus 6 times negative 4, the opposite of positive 4. And then this 6 is just whatever we factor out in the very beginning. Okay, so here and here, they need to be the same number. Here and here, they're going to be opposite numbers. Opposite in the sense that their signs are different. Positive 4, negative 4. Okay, so then bringing everything down, negative 19, and this is going to be negative 24. And then 6x plus 2 squared minus, what is this, 143. So then our vertex is then given by, if we set this equal to 0, we subtract 2, it's going to be the opposite of positive 2. So negative 2, and then negative 43. Okay. And that's our vertex. Okay. I think that should be good enough to get you guys through most of the Actually, let's do the very bottom. Let's do this one. Okay, so a rocket's height in meters is modeled by this function. This it looks like a quadratic, so it's given by this. Okay, where t is the seconds after launch. What is the maximum height of the rock? What is the maximum height the rocket attains? So there is a negative, so we know it's going to go down. It's going to go something like this, right? No, horrible. It's going to look something like this, and then we have a maximum height. So this is actually just another vertex problem. Can you find the vertex of this problem? Okay, so how do we find the vertex? First, we got to find our axis of symmetry, plug it in, and then find the y value. Our y value is going to be the height. So if I find the x value of my vertex, that's going to be the maximum height. So let's find the vertex. So it's not telling us to do it's not telling us to do completing the square or anything. So the easiest way to do this is just to do x is equal to negative b over 2a. Okay, so from our quadratic, we know a is given by negative 4.9. Our b is given by 29.4. And then our c is given by 2. So then our quadratic is going to be negative 29.4 over 2 times our a, negative 4.9. So on top, I have negative invisible 1 times 29, so negative 29.4 over 2 times that. Let's see what that is. So we have 4.9, negative 4.9. And this gives us negative 9.8. Okay, so now let's put in as a fraction. So negative 2.29.4 divided by negative 9.8. And I get 3. Crazy. Okay, 3. So this is the x value. This is going to be x equals 3. X equals 3 is going to be right here. So now we know what the x value of our maximum height. Now we got to figure out the height of our maximum height. So to find that, I just plug in 3 into my quadratic. So h of 3 is going to be negative 4.9. 3 squared plus 29.4, 3 plus 2. So plugging that in, negative 4.9, negative 4.9, 3 squared plus 2 point, nope. Okay, 4.9, negative 4.9, plus 29.4, 3 plus 2 gives us this, 46.1. Okay, so then our vertex is in 346.1, and then the maximum height, how high does it go? This is going to be 346.1. Right, our maximum height is going to be our y value right here, because that's how high our vertex goes, and our vertex is going to be either the highest or the lowest point of our parabola. So then our height is going to be max height is equal to 46.1. Okay, that's it. Okay, so the rest of the problems are practice problems. If you run into one that doesn't make sense, bring it to tutoring, or you can leave a comment at the bottom of this video or the Google Classroom post, and I'll answer it. Okay, bye-bye.